Okay, you can hear 100% infill. Huge thing here. This is also on island. I mean, can you even see it 3D printed? Oh no, even play around. It's very nice. So we are in the lab. 40mm cube. Whoa. Be mine. All our different materials. How do you guys like this? I think we are live. Hi everyone. How is everyone doing today? 3D Medic Beans, how are you? NSGO, thank you for joining. Tom from YouTube, how are you? Medic Beans from both YouTube and Twitch. Are you dual streaming the same stream? Chewy, thank you for joining. James Huffman, News. Dead Bazaar, how are you? Kenneth Sang. James, I just bought the stuff to do this. I hope I don't regret it in 1 hour. What do you mean? Which what did you buy? You mean the stuff for input shaping, or? I'm doing very good, Muse. Thank you. Okay, video and audio is all good. Okay, great. So today we'll continue the discussion that we started last week. We started input shaping. I don't think I have saved the PPT. Let me check. No, I don't think I have saved the. Or did I? No, I didn't save the PPT. But it's okay. I mean, we more or less finished what we talked about last week. Oh, okay, the input shaper kit. Okay. By the way, I don't even know what do you need for input shaper? Like exactly what's in the kit? So what did you get? LDO, the LDO one, LDO input shaper kit. So I guess there is what, an accelerometer for the tool head, and then the cables to go to the board directly, something like this. So what's in the kit? So you have, okay, so you have a mount, okay, depending on the tool head you have, and then I guess that's the what is this? The wiring. Okay, I guess the Pi, you already have it. It's not in the kit, I guess. And then where is the mount orientation? Blah blah blah. What's in the? Do they have a Pi in the kit as well? ASTL 345. Do they have a Pi? No, they don't have a Pi, right? I guess only accelerometer and the wiring. Where is there a bomb something, and maybe the mounts or something? Yeah, I guess you need to have a Pi already. Let me check. Wiring, the input shaper tool is simple. They don't have just input shaper toolkit, or maybe some kind of pictures. Okay, there you go. Yeah, there is no Raspberry Pi. So you have what is this? Okay, the wiring and this. So is this? Oh, so I guess this is the accelerometer because you have the X and XYZ here. So I guess this is what you mount on the. Oh, ADXL 345. Oh, okay. So that's what he was talking about. So I guess this is what you mount on the hot end, and this is what? Is that an extra stuff you have to put on the PCB? And then wire that to this, and then this. Plug it into the PCB? Is that what it is? Why there's an extra stuff here? Oh yeah, I guess so. Oh, so this is the thing that you plug into the PCB. Oh, because of all the pins. So the PCB have pins. This is just a kit which is more convenient for people who don't want to solder the pin strip to the ADXL 345 board. Oh, okay, yeah, got it. Yeah, so basically you plug this. So it's an easy plug basically. So it's an adapter, right? Adapter from this type of plug to the board, right? Okay. And then it looked like, okay. Oh, okay. Oh, yeah. Oh, okay. I got it. So you have all the pins here, and then instead of soldering everything to the pin, then you just put this adapter, and then you plug the accelerometer. Then you go all the way there, and then you put the accelerometer on your tool head. Okay. Oh, so you still have to 3D print something, right, to put it on the tool head? Or is there or does it mount on screws that are already available, like holes or something? Oh, it's outside. Okay. Oh, interesting. Okay. Makes me feel like I did something. I prefer to solder to a Pico lol and add second MCU. Okay. How much is the kit? Like how much is input shaper? Like adding input shaper, how much is that? Let me check. Price. Oh, it's $12. Okay. Free shipping. 150. Oh. Okay, so if you buy from LDO, you need to buy over $150, and then you can get free shipping. But the kit is only $12. Or maybe West 3D has this. They have a input shaper kit. Input shaper kit. Oh, they don't. Oh, so you really have to buy from LDO directly. ADXL 345 on AliExpress is 1.5 plus shipping. Really? Oh, it's so cheap. So accelerometer in general are very cheap, right? West 3D is great. They are in my area. Yeah. I heard a lot of great things about West 3D, and I'm very looking forward to meet them at Rocky Murph. Zombie, we are on West 3D because I wanted to check the price of input shaper kit, but they don't have, because I saw $12 on the LDO, but you need to buy 150 worth of product to get free shipping. Oh, ADXL, they sell the ADXL directly. Oh, okay, got it. Oh, there you go, input shaper toolkit. Oh, there you go. $12. Yeah, there you go. Okay. Yeah, it's okay. So it's not a huge investment, right? It's not a huge investor to add input shaper. And then I saw there is a software thing that you need to do. Input shaper kit. You go there, and then you have software installed. Before you can start running input shaper calibration, you need to install a few software package on your Raspberry Pi. Checking the setup, blah blah. Okay, got it. Well, the setup seems pretty straightforward, right? Not you mount the accelerometer on your hot end, and then you plug it to the PCB with or without an adapter, and then you install a couple of stuff apparently on your Pi. Software installation, yeah, you do this, blah blah. Okay. Test resonance axis. Okay. Yeah, maybe this will also help us to understand a little bit more today. Oh, great. I have a graph also. Okay. So you do need. Okay, that was actually my question. Is whether you need a Pi or not to deal with this, but you do need one. So okay, understood. $12 to avoid messing up a solder was worth it to me. Oh yeah, definitely. Input shaper toolkit, yeah, definitely. So you have, but I guess they offer the screws with it, but I guess it depends on your hot end. The LDO input shaper toolkit comes with all the necessary parts, performing clipper input shaper calibration with minimal hassle. Oh, does that mean it's only for the calibration? Does that mean that after you calibrate, they don't use the accelerometer anymore? Is that how input shaper works? Like the accelerometer is only needed, like the kit is only needed for the calibration. After that, then that's it. They are not going to use it anymore. Yes, you remove it. Oh, okay. Oh, you remove. Oh, okay. Oh, I didn't know that. I thought it was like a closed feedback loop. Like the accelerometer will give a continuous data to the Pi, and then the Pi is and then the Pi is somehow live changing the G code or something like this. Most people are doing this on the Voron. Then anything, you change anything, you only run input shaper once, or if you change something, yeah, okay. Anything, you change anything, you can move it between your printer. Oh yeah, then you only need one. Oh, that's cool. Yeah, so it's really minimal investment, right? You have two printer, that's like $6 per printer, because you use the same kit for both. You can also use any other PC if the PC has no SPI I2C. You need another MCU, for example, Arduino, Bluetooth, etc. You also install Clipper on it, which can translate the SPI to UART over USB for laptop. Okay, I know what is USB for laptop, for example. Okay, yeah, I know Zombie, for example, is using like an old computer or something like this to run his Clipper, not on a Pi. And no tangent. I'm talking about input shaper Edge of 3D, and I went straight into it because mainly because I have to stop in 2 hours maximum. I need to go downtown, so LDO also includes the ADXL kit in their Voron kit. Oh, okay. Hey, Builders Mark, how are you? Okay, so okay, so I just wanted to understand a little bit more about the setup. The toolkit comes with easy to install ADXL 345, lightweight FFC ribbon cable, and RPI connector board. I have no idea what FFC means. RPI, ADXL. I have no idea. I mean, I understand that it's this type of thing, but I don't know what it means. For easy connection between your accelerometer and Raspberry Pi. Okay. Oh, RPI connector. Okay, so that's how they call the small adapter. RPI connector. Okay. This is the input shaper doc page for more instruction. Blah, blah, blah. Okay, got it. Yeah, not too. So what is expensive when you buy a board? Like, why the Raspberry Pi is super expensive and this board is not expensive? Is it how do you call that? Is it the PCB? Is it the PCB that is expensive in the Raspberry Pi? Like what? Like, is it this thing that is expensive? This or maybe this thing? Which one is the which one is the important one? Like what components are expensive? Like, I don't understand why this is super cheap and this is super expensive. Is it the size? No, I'm pretty sure it's because of this, right? The silver thing is expensive. The main SoC. Oh, this thing, right? This is the thing that is expensive. Okay. Is that this that is called the microprocessor? Microprocessor, is that this thing? The CPU, right? CPU, computer, what? Personal unit? CPU. Control processing unit, right? So that's the thing that is expensive. Where is it? The ARM64 system on the chip, computer processing. Okay. So that's this thing that is expensive. So this thing. So what is the black thing? I thought the black thing was the one helping with receive the information and transform the information into something readable or something like this, and then send it somewhere else. Because there is also some black thing here. I thought that was the thing that was hard to get right now due to chip shortage. Okay, so that's this thing that is in shortage. Okay, understood. Anyway, I don't know so much about PCBs and stuff. Word shortage, Pi 4 is only around $40. Shortage drove up the price. Oh, $40. Okay, so it's not that much expensive actually in a regular time. The black thing is probably additional RAM because the Pi also come with 4 and 8 GB. The one on the Pi is RAM, and the one on the other is the accelerometer. Oh, this is the RAM. Oh, this is the accelerometer. Oh, okay. Okay, I got it. And then all the rest is some kind of resistance, right? Resistors, and some type of thing, right? Okay, maybe a little bit of a tangent, but I like this. I mean, it's also interesting, like how a PCB works, or like the different component is interesting. And it looks like most of you are pretty familiar with all the different stuff that is on that, because I have no ideas. Hey 3DHP, how are you? A Pi is crazy cheap when the word is normal. Okay, $25. Okay, yeah, so maybe okay, understood. Asks Nawaz, he is the master. Okay, yeah, we'll have to invite him to explain about PCBs in general. But anyway, okay, got it. So you buy $12, you install it, you run the test. I mean, you install the software on the Pi, and then you run the test, and then you remove it. Okay. Okay, so you were saying we only need to run the test if we change something. Is there some type of maintenance with input shaping? Like, for example, you level the bed. Theoretically, you level the bed one time, right? But as you are operating the printer, you have to re-level the bed, blah, blah, blah. So is input shaping the same? Like at some point, after a certain amount of use of the printer, you better just rerun input shaping. Is there this type of thing also? Yes, if you change the belt tension. But let's say you don't change anything. You just the fact that you operate the printer for I don't know, a week. Is it after a week of operation you need to maintain it, which means you need to rerun that? There are so many other options for single board computer and tiny PC that it really doesn't matter. Okay. If your belt wears and become loose and you tighten it again, it could become slightly off. Unless you change something, you don't need to do it again. It can go for years. Oh, okay. Okay, so there is no... Because, for example, you are talking about tightening the belt. So that means the belt will loosen over time, right? So theoretically, the input shaping data are not good anymore, right? You have to retighten the belt in order for the data of input shaping to match again, right? Why if you retighten it, then you have to recalibrate? Correct. Okay, yeah, okay, I understood. Yeah, okay, I think I get it. So, yeah, I think it's pretty clear. So we were talking about, so last time, if you remember well, we went back to the basic and tried to understand why we need input shaping, blah blah blah, and then we talked about that the real issue is not really vibration or resonance or something like this. The real issue was the amplitude at which the printer will flex, right? And I had some further. It was too hot. Now it's too cold. I had some thinking on the printer flexing, and actually, do you guys think? Because I mean, I have a hard time to imagine that the printer is really flexing just because the hot end is moving, right? I mean, we're talking about extrusion aluminum rods, right? And so what I was thinking is, can I say that the only thing flexing, or let's say everything is negligible, the main one is the belt. It only depends on the belt. Can I say that? Which means if you have a printer without belt, okay, like you have how you call that? How do you call that? The one with ball screws. If you have ball screws on all the axes, then there is a very, very high chance that you don't need input shaping. You won't have that issue. Can I say that? Can I say that it mainly comes from the belt? If you don't have belt in the system, then you won't have that elasticity that creates this amplitude of flex that is disturbing your print. Are you saying that aluminum doesn't bend? No. I know it bends. What I'm saying is it's negligible. Like if you have ringing or ghosting, whatever you call it, it comes from the belt. It doesn't come from maybe. I mean, yes, the aluminum flex, but you won't be able to see it. Depend on the acceleration on the frame. The frame also flexes. Mostly flexing because of heavy print bed on an IT. Yeah, for bed slinger, okay. But same on bed slinger. Maybe it's also because of the belt that is driving it. Yeah, lead screw core count. Yeah, lead screw. There you go. I bought a Dell Wise Thin Client off eBay, $25. It will run 3 clip per instance, no problem. Okay. That's much cheaper, Aaron. That's much cheaper than getting a base. Yes, but the curve you see showed the attenuation of the shaper. It will also get slightly off frequencies, but if you want it spot on after a change in belt tension or other relevant mechanical change, you can run it again. It's finding resonance of the system, so the belt, the shake of the table, etc., but it has part where it would throw it off, but not much. Okay, got it. I guess ball screw will perform much better if no input shaper. Okay. On your Ender 3 S1 at 500 meters per second square, it will probably not be so relevant how the frame behaves. If you want to run it at 10,000 meters square, then the frame also becomes relevant. You put your hand on it and you can feel the vibration on the frame. Yeah, but like we said before, Sebastian, vibration doesn't really matter, right? If the whole printer vibrate is not going to affect your print. What's going to affect the print if it's flex, right? If the whole thing vibrates and then I touch and it vibrates, okay, but it doesn't matter in the way that if it vibrates without flexing, it's fine. No input shaper still made a difference on my Voron Trident. The Trident also used belt, right? Why? Does it? Yeah, of course. Does it? Or is it me? Yeah, you use belt. Yeah, it's a core XY, and then yeah. Why are you saying this? Yeah, it has lead screw on the Z. What I'm saying is that if there is a belt in the system, that's where it's gonna come from. Like for example, if you have lead screws on the X and Y, then most likely you will barely have any ghosting issue. So my point is that it's really because of the flex of the belt. Like if you suddenly accelerate, then you will really stretch your belt, and then you will want to come back and then go and then come back, and then that's creating the issue you have on your printer. But is that really if the whole hot end go on one side and then suddenly change, you have your the frame that is flexing or something? Like first the belt is gonna damp all of that, right? The belt is gonna absorb all that energy. And is there enough energy that is going back to the pulley and then to the frame and then flexing the frame so that the frame is out of alignment compared to the rest? I don't know. I have a hard time thinking that. That's why I was thinking it's really about the belt. Like I would put belt number 1 and all the rest very, very far negligible. Yes, it's also the frame. You even notice if the printer frame is bolted down on the table or not in the graph. Bolted down to the table or not in the graph. Flex is to macro. Input shaper is for harmonics and resonance. It's the whole machine. What do you mean, TomTom? Flex is to macro. Input shaper is for harmonics and resonance. I think the majority of vibration is from bell. Yeah, I agree with that, Ernesto. Well, is there any printer? I've seen a printer on YouTube that was lead screw everywhere. What was the name of that printer? I saw on, I think it was on YouTube. I saw like, oh, the Pantheon. Yeah, the Pantheon. But like this Pantheon, for example, is there any some, it was that printer. Can you guys hear the video, or do we have the same problem as last time? Can you hear the video? Like for example, this printer. Can you hear the video, or? You cannot hear it. Okay. Anyway, he's not talking about. Somehow, no sound from the video. Okay, that's very strange because on StreamYard, sometimes I share the screen and you can, and sometimes you cannot. I don't know. I don't understand why. Okay. Anyway, so that printer doesn't have any belt in the system. Like how important this input shaper would be for this one? Like, would you see a difference? Like, would you eyeball a difference? Like, if you take a print with and without input shaper with such a machine at very high speed, I mean, it's printing pretty fast, right? Would you see any difference? Because yes, it's vibrating. I agree, but again, vibration doesn't matter, right? What matters is whether it's flexing. Because if everything vibrates, then it will still print at the right location. But if it flex, then the hot end may print outside of where he should print. So that's the issue, right? And that's why it's creating the ghosting. So such a printer, yeah, I mean, I don't know how we could answer that. We should ask this guy directly. I don't know if they are very active. Let me see. Their latest video was, oh yeah, their latest video was 1 month ago. Manufacturing update, building a press jig. Okay. So it's the story of, they want to release that printer as a commercial printer. Okay. So yeah, what do you think? Hey, Incendium, how are you? Sebastian, the whole system frame still has resonance frequency. Yeah, vibration at the frequency of the resonance frequency will still induce the same effect. Vibration of the frequency of the resonance frequency will still induce the same effect. But again, it's because of flexing, right? Frequency of resonance is going to naturally increase the amplitude, and then the amplitude, the higher it is and the more it has the risk of flexing your printer, right? But I mean, yes, theoretically, everything can flex, right? Everything. My question is, to what extent? Like, is input shaper really useful for a printer that doesn't have belt? Like, I'm not looking for the answer, like, the theoretical answer that would say, yes, theoretically there should be some type of vibration so you can get rid of it or something like this. By the way, remember the question we asked last time, right? Is input shaper only useful for getting rid of ghosting, or is it useful for something else? You know, last time we said that yes, it is only useful for ghosting and like getting rid of ringing, but maybe it can improve the speed performance of your printer. But we couldn't explain why. So if you guys have, you know, would answer the question differently, then let me know. But as of right now, it's only about ringing. And actually, you can see here, there is no ringing, right? So I don't know if they use input shaper or no, and I don't know if the reason there is no ringing is because of the input shaper. But yeah, that's kind of the question. Oh, you're sick? Okay. Hope you will recover soon, Incendium. Mike, thank you for being awesome. TomTom, it still vibrates, and yes, input shaper would affect it. A rock still has resonance frequency. Yeah. TomTom, I understand this. I'm really going back to whether it's useful or not, because the goal is that, you know, the goal of input shaper is to have a high quality print, right? On that type of printer, whether you have input shaper or not, I guess you will still have a high quality print. No difference. No system is perfectly rigid. Yes, no system is perfectly. Yeah, I agree with that. Vibration, blah, blah, blah. Sebastian, you have multiple peaks. The biggest peak come from the belt, but the smaller peaks in the graph come from the frame, etc. So it has a use even for the non-belt printer, just a smaller one. Okay. Oh, the peaks are... Oh, I didn't know that. So what you're saying is these different peaks represent resonance of different part of the system. Is that what you're saying? Like, for example, this is for the belt, this is for I don't know, the horizontal extrusion, aluminum extrusion frame. This is for the vertical one, something like this. Is that what you're saying? I didn't know that. Pantheon also have a thick top plate that mount all of the motion component, which also add to rigidity. Come out in PLA. How are you? I'm doing fantastic. I love this type of stream, like the Printbusters stream. I really like it. I mean, I like the review on Tuesday, but I also really like the Thursday one. 3D dimensional print. No, the resonant frequency is a number used to break up the input commands at intervals inverse the frequency. So no matter the move or direction or speed, it will be countering vibration through timing of command. No, the resonance frequency is a number used to break up the input commands at intervals inverse the frequency, so no matter the move or direction. Yeah, but depending on the move and direction, the resonance of frequency will be different. Depending on the move, the direction, the speed, all the factors that we explained last time. In the last stream, I think it was position, acceleration, jerk, and direction. So there were 4 factors that would influence the resonance the frequency and resonance, or at least that's what. Not will affect the frequency of resonance, because frequency of resonance is intrinsic to the system. Sorry. What I mean is will affect the frequency at which the printer will vibrate. Okay, so let me repeat. The 4 factors will affect the frequency at which the printer will vibrate. So if you move in that direction, it will vibrate at this. If you move at that speed, it will vibrate like this, blah, blah, blah. But yes, the frequency of resonance is intrinsic to the system. So if the system doesn't change, the frequency of resonance will be the same. Yeah. Sebastian, my Anet A8 with the acrylic frame looked way worse. I guess in that case, the resonance frequency will be much higher, which may not affect as much at printing speed, and the amplitude is much smaller than bed. Correct me if I'm wrong. I think you're right. If the more rigid the system is, the higher the resonance of frequency. I think it makes sense. I think it makes sense. You think? Yeah, I would say so. And then the amplitude is much smaller than the belt. Yeah, I mean the amplitude is if you really reach the resonance of frequency, then the amplitude will increase in any case, will naturally increase. And yeah, for the more rigid the system is, and the lower the amplitude. Yeah, I think I agree with you, NSTO. So the more rigid the system, the higher the resonance of frequency, and the more rigid the system, the lower the amplitude. I mean, even though it increases over time, but yeah. Sebastian, I sent you a picture of how a poor quality frame looks on Discord. Okay. Did you send it on off topic? Or somewhere else? Or general? Oh, here. Oh, here, there you go. Okay, so this is, let me open it in the browser so we can zoom in. Oh. Zoom in, let me go back here. Okay, so this is, okay. Okay, so what you're saying is, what do you mean by a poor quality frame? Means like not rigid, and then you have different resonance of frequency of resonance. Sorry. Okay, we'll use that chart later once we get to the chart. No, it won't change. Printers have one peak frequency. All other will be negated at the inverse vibration of the peak frequency. That's why it is input shaper. Yeah. So yeah, there is only one peak frequency of resonance. Actually, theoretically, this graph will be the same. However, no, actually this graph, let me think, depending on the frequency, yeah, this graph will be the same, whatever speed or position or blah blah blah, then this graph will be the same. Polymaker, there are around 5 pi alternative, Orange Pi, BTT Pi, CB1. The cheapest way is to buy the ADXL sensor of Alibaba and solder it yourself. You have to run input shaper again eventually because ABS print head or other ABS parts will creep after a long time, and sometimes screws come loose. Oh yeah. So that's what I was thinking. Like maybe input shaper is part of the maintenance. So you have every once in a while, then you have to rerun input shaper. Yeah. And okay. So there is much cheaper way actually to get around the price increase of all the pies. The input commands help the shape. The input command help the shape. What the shape means? No, it won't change. It will negative the inverse vibration. Shape meaning shaping the curve. So what the input command will help shaping the curve. You don't have a huge belt peak, but also a lot of resonance in the frame. How do we know which one is the frame and which one is the belt? How do you know that? Like, how do you know this big one is the belt and this one is the frame, and then this one is what? Like, how do we know all of that? Cannot stay. I'm putting together a solid presentation to share with you on this. I got to the bottom of it, but I cannot type fast enough. Oh, that would be awesome, 3D print. You're very welcome to join the stream next time if you wanna present all of that. I know you cannot stay today, but maybe next week same time. come and do give me a teaching lesson on this. That would be very helpful. I mean, more than me, right? I'm pretty sure a lot of people in the chat would love to have a more detailed presentation on that instead of watching me trying to figure out. James, active continuous input shaper would be cool. Just an integrative accelerometer in the toolhead PCB. Yeah, Jeff Husman, I thought it was this at the beginning. At the beginning, I thought it was this. I thought it was some type of accelerometer in the hot end, in the printhead, and that continuously send data to the Pi, and the Pi adjusts the command so that it prints well. I thought it was something like this, but it's not. I guess maybe because the feedback loop would have to be the system is too slow to do that, maybe. For sure, DM a short video on Discord you could share. Okay, you mean today, or oh, you mean you do the presentation in a short video and then I share it on Discord, and then I share it during the stream. Okay, got it. Yeah, of course. Whichever way you want to do it. If you want to do it live, or if you want to do a YouTube video and then I show it on the stream, whichever way is good. Thank you so much, by the way, for taking the time to share your knowledge on this. Loosen bell running again. Check which one moves. Oh, what do you mean, Sebastian? Okay, so you are trying to answer the question that I just asked, which is, how do we know which peak is what, right? So loosen the bed, run it again, check which one moves. Oh, so theoretically, let me know if I'm correct. If you loosen one of the belt and then one of the peak is suddenly increasing, but all the other are the same, then it will show that this peak is that belt that you change, right? Oh, yeah, okay. Oh, so maybe, okay. Then how can you do for the frame? Like change one part of the frame to a higher quality one and see if this one decrease. Okay, yeah, that would be a bit too much work. Really not loving the music loop, very distracting. Am I the only one? Is there any music? Do I have any music running? Oh yeah, I have, sorry. If it's distracting, I just removed it. Then should be better now. Kevin, let me know if it was my music or something else. I just removed it. Don't mind the graph, just rise the preferred algorithm and frequency. Use the preferred, yeah. Sorry, I'm working on the camera, blah. Music is too loud, it's the volume. Okay, I just removed it. Let me know if it's better. I think, I couldn't hear it. That's why, because my volume was very low. It will not just increase it, it will move around like a guitar string with a different tension. Oh, yeah. Oh, yeah, you're right. Of course. Yeah, Sebastian, it will move, and also the amplitude will change. The frequency will change. The frequency of resonance will change, and the amplitude will change. Yeah, okay. Got it. Much better. Okay. Yeah, if there's anything you want to change, just say it in the chat, right? Only Kevin talked about it, but a lot of people react to this. But if there is anything, just say it, like music's too loud, or music's not good enough, or whatever, just say it. Your voice is the music. Okay, so what was the topic? Yeah, the topic was whether or not the belt was the main issue. So yeah, I mean, we don't have much. We don't have experiment, or we don't have much to show. We do have this graph, which Sebastian. So I don't know how to confirm it. I mean, for the belt we can, but what he's saying is this is the belt, and then this is the rest is like other part of the system, which is most likely the frame, right? And then if we look at the one that was as an example here. Then you have a very big one here, which I guess is the belt, and then you have two small ones. So you can always say one big one, but there's another. I mean, there's a lot going on in his Anet A8, I guess. But can I say that this is more or less what most of the people have, like a big one? There's nothing before, then a big one, and then later on. Oh, yeah, we just talked about the more rigid the system and the higher the frequency. So maybe what we can say is that this is the frame in a way that the frame is very rigid. So it is normal that we see the resonance of frequency to be higher, right? Now the question is, what is this? What is less rigid than the belt? So it could be something like it could be something like this, because you can see the x amplitude here is the highest, and then here is the y amplitude. So maybe he has one belt that is more loose than another one, or maybe I don't know. The Anet A8 is what's the motion system? How is the motion system on the Anet A8? Let's try to be an expert at reading graph. Okay, so this is the Anet A8. So there is okay, lead screw, and then you have one belt here. Oh, the bed. Oh, it's a bed slinger. Okay, so that would make sense. So can you remind me which one is the X, which one is the Y? The bed is the Y or the X? So I would say is the Y. Why? Because I would say this is less rigid than this. This will tend to have a very large amplitude and a very low frequency of resonance, the belt, because of the mass and the flex of all the belts. So I would say it's the Y. So I would say this is the Y, this is the X. So that's why you have this. Bed is Y. Okay, so and that makes sense, right? Because it has a lower frequency of resonance, because it's less rigid. So I guess the reason why he has this one before the big one is because of the bed, and you can see the Y here. But theoretically, so here he was testing the raw data on the X. So even on the X, you have the belt. So even he was testing this direction, then the belt was moving. The bed was moving. Let me think. Why? He was moving like this. Yeah, I mean, either his accelerometer was not really in line with the printer, either even if you move on the X, then the bed slinger was so loose that the bed was so loose that it was also moving on the Y axis. But anyway, so you have these, and then you have that this one, and all of these could be part of the frame. Okay, so that's how I would analyze this graph. Y did not move. Well, why did not move? Well, it did, right? Well, I mean, it vibrated, right? It has to move, otherwise the green one is the Y. If it didn't move, then the Y would. I mean, the Y of the accelerometer, right? The Y of the accelerometer. Motor not engaged on the bed could cause it to move. Yeah. If it was mounted on the head itself could be loose. Oh yeah, could be also. Yeah, that's a good point. Bed is Y, chart is just for the X. Okay, Y, yes. Loose fitting on the head, yes. Loose screw, yeah. That's probably an Anet A8. There's Voron. I asked about it 30 minutes ago. You probably missed my message. Sorry, what did you ask, non-fam? 30-minute long. There is a how to read and analyze input shaper graph generated by Clipper, video by 3D printer, and whiteboard on YouTube, which shows how to interpret it, but it's way too long to watch now. Yeah, we've had some videos, but it was too long. But I will try to watch it off stream. It's the linear bearing, probably. Thank you for being awesome, Tonya. Thank you for being awesome. OH Bush, Wookie. Okay, got it. So after you have all of this frequency of resonance, so what do you do after? So maybe a question is why. So why do we care about frequency of resonance again? Okay, so like we said last time, we care about this because this is the frequency that which create the most amplitude and which will flex the printer the most, which will impact the quality the most. And the other vibration, we don't care. Right? Is that or not that we don't care, but actually why we even talk about frequency of resonance? I mean, what we care is the whole thing, right? We care about how the printer react at all the frequency, right? Whether it's resonance or not resonance, we don't really care, right? It's just that if we want to improve, it's just that these big power spectral density is the one that will affect the quality the most, right? Okay, I got it. So, okay, so what's next? Hey, Toronto Dan, thank you for being awesome as well. You choose a shaper, the dotted line. Okay, you choose a shaper. So after we finish that, we choose a shaper. In this case, I took MZV. MZV. Okay, so all the dotted line are different algorithm to dampen the frequency. Am I correct? Nordic Skull, how are you? Thank you, DMAT, for being awesome. In that case, I took him 26.8 hertz. It also attenuate at 90 and 130, as you can see, but not so much. Actually, print fines. Okay. Kenneth saying it doesn't have to be the printer moving. It can be an entire table moving. The input shaper can counteract that too. It can be the entire. Yeah. That's true. It's really the whole system. Yeah. But again, so the input shaper. Yeah, again, so that's why I like to go back to the beginning, because at the beginning we said that vibration is not a problem. The flex is a problem. So input shaper is also dampening or attenuating vibration that maybe we don't care. Maybe they're not affecting the print, but it still do something for it. So it cannot differentiate. Okay, so I guess that's the limitation of input shaper. It cannot differentiate bad vibration to good vibration. Am I correct? Like it's going to make sure the whole printer is not vibrating, whether it affects the print or not. Vibration is flex. I disagree. Why vibration is flex in Sendium? I don't think vibration is flex. Well, I don't understand the logic in Sendium. TPU fit on a solid table. Yeah, TPU fit, yeah. Yeah, so who was saying that? Chewy, that's what we talked about. We talked about it last time, right? Whether TPU fit was a better investment than input shaper. But again, we'll have to test that. But yeah, if the goal is to dampen all the vibration, then but anyway, what you just say, like, is it better to have foam? Is it better to have foam under the printer? Because I mean, if you check this, you have some people. I mean, before input shaper, we solved the problem by putting foam under the printer, right? If you remember that, and that solved the ringing problem. But the printer still vibrate a lot, right? But the fact that it's not stuck to the table, then that solved the ringing issue. the input shaper can't know where the vibration is coming from, the printer, the table sitting back, or the car rolling down and bumping around. Yeah. So one don't affect the other. No, it's just disconnected from each other's. Tall print on table wobble could be bad, I would think. Yeah, but again, I think vibration is not flex in my opinion. Unless the printer is perfectly rigid, if it vibrates, that vibration moves through the printer as flex. Yes. Let me think. Yeah, yeah, I think so. Yeah. So I mean, my point is that it's different, right? Vibration and the printer flexing is different. What we care about is we want the printer to flex as less as possible, the least amount. Okay, we want the printer to flex the least amount. Okay, and right now is the belt. The belt is the big issue. The rest, it doesn't flex to an amplitude that really matters, at least for quality print. Watch Nick Chris Baseman video on YouTube. Chris Baseman put his printer on marbles. Yeah, and actually, if you remember at CES 2018, I think, or was it CES or maybe Formnext or another one, Loosebot put the printer on a swing, put the printer on a swing, and it was printed super well, like very, very nice quality, and there's definitely no input shaper. Where the shapers are down in the graph, they will reduce vibration at this frequency. If the printer does not resonate on the frequency at which it does not attenuate, the vibration will not build up too much. Where the shapers are down in the graph, it will reduce vibration at this frequency. It will reduce the amplitude at this frequency. Okay, I try to use vocabulary so accurate so that we can have a proper understanding, right? If the printer does not resonate on the frequency at which it does not attenuate, if the printer does not resonate at the frequency at which it does not attenuate, the vibration will not build up too much. Okay, the amplitude will not build up. Okay. Yeah. Okay, understood, Sebastian. And diminish resonance. Yes, okay. Noise cancellation, same principle. Okay, thank you for being awesome, Stone Monkey. Okay, so we have the different amplitude in function of frequency. So let me summarize a little bit. When you print, the head is going to move at a certain acceleration and direction, etc., and that will induce vibration in the system at a certain frequency. Okay, and then we are trying to attenuate that frequency. Maybe a quick question for you guys: how the G code is telling the printer an acceleration, a direction, a speed, etc., right? How does the printer knows? How does the printer knows? Oh yeah, it does know. Yeah, because remember that the printer is not actually changing frequency, right? Okay. So let's go back to the end of last stream. Remember that the printer is not testing frequency, right? It's testing, I mean, it's not changing directly frequency, right? It's changing the acceleration. That's what the printer was doing, right? It's changing acceleration. The frequency is just to have a better understanding. But Oh, I'm breaking my stuff burner. It's pretty solid. Galaxy ABS. ASA, sorry. This one is Galaxy ABS. What I was saying. Yeah. So it's testing different accelerations. So that means when it receives the G code, it will know that the system has asked a certain acceleration. So it will know that at that acceleration, it will vibrate at that particular frequency. So it will start to do the shaper, right? Because it has to know the relationship between G-code command and the frequency that will result from that movement. So the question is, how does it do that? And I think it does that by calculating the acceleration every time there is an action going. Every time the printer is receiving a command, it will calculate the acceleration, which most likely is in the command, and it will deduce from that acceleration the frequency at which the printer will resonate, not resonate, will vibrate, and it will put the shaper that you have chosen. So it does quite some big hypothesis, right? So it's bulk parking a lot of stuff, but at least I understand. Where is our Galaxy ASA? I got mini stuff burner to print. Yeah, sorry, because of Chinese New Year, we had to move that. We had to delay that. Input from G code shaping. Sorry, what do you mean? Hey, Steve Beard, how are you? Steve Beard has so much knowledge that I think you will be bored in this Printbuster stream. Like we're talking about input shaper. How does it work? I'm trying to understand how it works. That's how it predicts it. That algo you picked. Yeah, but the algo, I don't think so, because the algorithm is based on the frequency. So you input a frequency and then it gives you the amplitude over. I think it's different. Magic, yeah. It's pretty much magic. You are thinking out how the input shaping system uses. So what I was, let me just go back to see if I didn't miss anything else. Blah 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 blah. Okay. Yeah. So what I was saying is, you need to know the frequency in order to know how to react, right? Input shaper needs to know what is the frequency, so that it will know how to counter it, depending on the algorithm, right? But how does it know that frequency? And what I was saying is, it doesn't, when it does the test, it doesn't test the frequency. What it does, it slowly increase the acceleration of your printer. And then it waits until it arrives to whatever, 200 hertz or 133 hertz or whatever you have set the range, right? So it knows the relationship between acceleration and frequency. And the G code is giving, every time the G code is giving a command, is giving a certain acceleration, right? There is a certain acceleration, so that it will know whether it's zero, whether it's minus, whether it's positive, blah, blah, blah. And then it will take that acceleration, convert it into a frequency, and then that's the frequency that the system will react to. Does that make sense? Fancy math and stuff, and some magic too. Nicola, do we have to be here to win the spool? It is late here. Yes, you have. If you want something where you don't have to be there, you can go on our Discord. We have a weekly giveaway, so you can go on the Discord and just enter the giveaway there. And there is a lot of partners that do giveaway where you don't have to be there also. Okay, so does that summarize it well? Okay, you test acceleration, and correlate with frequency, and then the G code is giving acceleration, so that you know by the correlation of your test to which frequency of vibration it will correlate to, and then you can react. Edge of 3, I just posted some input shaper and belt resonance in general. Frame on non-bed slinger. General. Here's input shaper from a non-bed slinger as well as belt tension utilizing the ADXL. Why is always opening there? Oh, okay. So frequency. Whoa, interesting. So this is on the Y. This is what printer? A non-bed slinger, belt resonance in general. I just posted input shaper and belt resonance in general. Okay. This is Y. This is X. So what is this? Oh, comparison. Y-axis. So okay. So most likely this is the belt, and then something here. Maybe the other belt. Maybe the. Let me check. No, this is Z. And then maybe the frame here. And then on the x-axis, you have a picture of the printer. Top graph is belt tension. Oh, top graph is belt tension. Belt tension? What does that mean? Oh, so the blue one is before you tighten the belt, and the orange one is after you tighten the belt? Is that what you're saying? Are we input shaping today? Yes, Leighton John. We're trying to understand. Input shaping. G-code does not need to give an acceleration. For example, even Marlin without input shaper will ignore the requested acceleration if the max machine acceleration is set lower than that. I mean, it does not need to give an acceleration, but we can calculate the acceleration, right, from the G-code command. I mean, in any case, the printer, I mean, the Pi needs to know what's the acceleration. Otherwise, it cannot implement the algorithm. It has to know. Mercury 1. Mercury 1. Okay, so that's the printer. Top graph belt tension, blah, blah. No, the blue is the left belt, the orange is the right belt. Oh, it's a core XY. Okay. The blue is the. Oh, okay. Oh, so you make it vibrating at 45 degrees and then minus 45 degrees, so that only one belt is engaged. Okay, got it. And then okay, so that's the printer that yes, okay, got it. Oh, so we can compare. Oh, that's cool. Okay, so let's take the right belt, or whatever, the orange belt. So the orange frequency of resonance, but what? Oh yeah, because okay. So the belt has a frequency of resonance of 55, 60, 60, 70 hertz, and then I don't know, something is happening at 125 for one of the belt, but let's take 70 hertz. So that's for the belt. But when you do a Y movement on the core XY, then you mix both belt, right? And when you mix both belt, then it lowers down to 50 for the belt, and then most likely on the and as you involve the same belt to go to the X, then it should be, then this one is 70. This one is 50 and the other one is 70. Yeah, I don't understand why. Okay. I don't understand. Belt attention to 125 hertz. What does that mean? Belt attention to 100 and... Oh, you have tensioned the belt so that the frequency of resonance is 125? Never do I. Okay, yeah, I will spend a little bit more time making some hypotheses there, and then I will check. Thank you for sharing, Sebastian. I will check that video also. I tension the belt at 125 hertz with a tuner. Oh, wait, what? Do you mean like a guitar string? Do you mean like you tension then and then you do ding 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 until it's 125? Really? Oh, I didn't know that's the way we I didn't know that's the way we tension the belt. Okay. Okay, that's interesting. I didn't know that's how. So they do that a lot on Core XY and XZ printer. Okay. Oh, that's interesting. I didn't know that. Okay, so yeah, like I said, I will have to leave in 30 minutes. On the way to get them even. Okay, that's very interesting. I didn't know. Okay, so let's try to talk about this dotted line, right? So the dotted line are different shape. So you call that shape. So it's a different algorithm, right? I've never really heard anyone talk about belt tensioning. Yeah, that's the first time I hear that way of tensioning. I mean, usually I see people just tensioning, but without particular data to know when it's tension or not. Just feeling. I want to get rid of belt and have ball screws instead. Yeah, I mean, in my opinion, that all of these issues come from the belt, because that's the part that is flexing in the system. I think the rest, not too much of a big deal, I would say. Dotted line. You usually want to use MZV because it's less aggressive. The more aggressive filters, you round off your corner. Okay, so that's another thing that I want you to talk about. I thought the input shaper would not affect the nozzle path, but it seems that it does. So it's very interesting. Dotted line are the different input shaper algorithm. Yeah. Like for me, I thought that it didn't affect. Like if the printer had to do this, then it would do this. But the input shaper is changing that. It's changing the way. It's changing the nozzle path. So yeah, I want to understand why it's rounding off. Like, okay, PPT time. Let's try to understand why why a corner would be rounded off, rounded up, rounded off. How do you say? Rounded out. Rounded. Why it would be rounded? It's kind of a low pass filter. If you apply a low pass to a square corner, it will become a circle. It's the effect of smoothing. Yeah, but I don't understand. Like, yeah, I mean, I can say going from here to there, I have smoothed out the corner. Okay, but what does it really does? Like, what does it do? Why? Like, we're talking about frequency. We're talking about attenuating frequency. What does it has to do with my print dimensional accuracy? You get what I mean? What does it have to do with that? So I have my line that do like this, and then my line that do like this. Okay. And then for some reason, the printer is going to change that. The PowerPoint especially. These are trapezoidal curve or S curve in the algorithm, as far as I know. There is something about running it on the FLSUN that removes fine details on print. So is it frequency smoothing? I wonder if better belts would melt out the metal or something. There is a James Hoffman. I've heard of belt with actual metal rods inside, something like this. Maybe these have less flex. A perfect corner needs the head to instantly change direction. A rounded corner is a slower change in direction. Yeah, you need to explain that to me off stream. Okay, so yes, so how does it work here? So let's do the graph. Okay, let's do this. So let's have our speed, acceleration, and all of the graph that we like so much, right? So let's go from let's say this is A, this is our point A, then we go to point B, and then we go to point C. Okay, and then we have this one here. So we have our A here, then we have let's go a bit longer. So let's draw speed first, okay? And let's say I start here. Let's say I start here, and then I end here. So if I draw the speed, then obviously I will start. My guessing is I will start with an instantaneous push, and then an acceleration to reach my top speed, right? And then I will have to decelerate to a certain jerk value. We did that last week, right? And then we re-accelerate, and then we decelerate to a certain sudden stop, right? And then and this stop should be the same as the beginning, I assume. And then what we said is we define this as the jerk, right? The instantaneous change in acceleration in acceleration. So we define this as the jerk last time, remember? Okay, jerk. Okay, and we define the slope here as the acceleration. So let me write accel, and we define this as so this is my speed, right? This is my speed, and this is position or time. So let's put position. Okay, so the issue that is going to happen here is this instantaneous change in acceleration, right? So the fact that you go from I don't know, minus 20 millimeter, well, let's say minus 2000 millimeter second square, and then you change that to 2000 millimeter square. Okay, so that's a certain jerk, which I don't know, but okay, so this change is what is going to create a vibration. Am I correct? Less stretch. Metal fiber belt are terrible for printers. The bend radius of the pulley is too small and break the metal strand. Oh, okay. Bricor, Justin, how are you? I just sent you the Justin. I sent you the thing for Rocky Mountain. Oh, by the way, Edge of 3. Did you release your video? we have a form that I shared on the Def Racer channel. If you guys are going to a Rocky Murph and you want to participate to the Def Racer, the PB Racer, then we will sponsor spools for that. I was thinking of maybe I will make the official announcement later on Twitter once Edge of 3D will release his video, and then we'll do that. But yeah, maybe you can help spreading the word after Edge of 3D released the video. Okay, so a 90-degree turn, no matter if it's in a square wave, in electronics or mechanically, does practically not exist. It would correspond to an infinite high frequency. If you would look at the FFT, the fewer order of frequency you use, the rounder the corner it gets. Yeah. Redoing the video, we have a confirm MC for the event. I'll have it out tomorrow night. Okay, cool. Oh, Major Gamer, you're going? Okay, great. Yeah, make sure to fill up the form then, if to build your racer. Okay, so this change in acceleration will create very high. Will create a certain frequency. Okay, so we'll create a certain frequency here. Okay, and then you will create an amplitude which will flex the printer and create some issue. So what we want to do is, what do we want to do? What are we trying to do? Why rounding out this corner will help? Because I was thinking in my mind we need to lower the frequency so that it's better, but actually no. Whatever low frequency or high frequency, it doesn't matter. It will still have issue. What we want is what? We want to lower what? We want to lower the jerk? Is that what we want to lower? We're trying to lower the jerk. So if we lower the jerk, then I understand. Because if you lower the jerk, it means you will have to have, let's say, now you have B1 and B2. Okay? And now you have something like this. Okay, you have some type of additional thing. Okay? So if you have this, then the jerk here is going to be, yeah, you have to, okay, so we have to go to an x, we have to divide the component so that we have a better understanding. Okay, so I'm going to lose a lot of people here, but I need to understand that properly. So if I have, sorry, I'm in my small bubble trying to get understanding, but let's say if I have, so this is my x and this is my y. I love this type of thing so much. Okay, so this is x and this is y, and then okay, let's not care about negative, positive, or something like this. So let me put that here so that we only have positive value. So I have B1, my C value is here, my B value was there, and B2 is here. Okay, so this is, it goes X, and then you need to change to Y. So let's go back to the one we had before. So if it does like this, then we have the X component that will accelerate, reach a speed, and then decelerate to 0. Okay, so the component is like this. Okay, the X component, and then here will suddenly go to 0. So that's here, something like this. Okay, we have something like this, and then let me remove this. Okay, so it suddenly go to here, and then accelerate, then top speed, then decelerate, and then disappear. Okay, at B. And then my Y component will look like this. Okay, we're good. So now in red, let's do the same, but if we break down this to see if that's lower. Do we agree that we want to lower the jerk, right? That's the instantaneous change. That's the thing that is moving the printer, right? So what if we want to do something like this? Is that lowering anything? If I do something like this, because you don't have to slow down. So let's check. So now, if we put that in red, so let's put that in red. Okay, so at the beginning it does the same, and it arrived to B1, and then at B1, it will decelerate a little bit. It will decelerate a little bit to half, right? To half, and then you will have a small jerk here if you do the calculation. And then it will continue this way. Am I correct? And then it will continue this way. And then when it arrives to B2, it will decelerate, right? It will decelerate, and then completely stop directly. Something like this, right? It will completely stop here. Okay, so we have divided that instantaneous change into two small change, and the y, and then the y is the same, but in reverse. So it will have a small change and then another small change. So that this breakdown has lowered the amount of jerk that you have. Okay, yeah, that makes sense. And then the more you break down here, if we want to break down even more, and the more we are going to divide that jerk. Is that correct? Did I lose? Did I lost everyone? Nobody is speaking in the chat. Okay, I guess at least that's how I understand it. I mean, I didn't check anything, but that's how I understand it. Because the most important is the jerk. We keep talking about acceleration, but I think the most important is the change in acceleration. So actually no, I think I was not very accurate. Actually, what's happening is when it does the back and forth, it's actually yeah. I think let me oh my god, yeah. Let me do that. Let me do this. Let me do my my beautiful hot end. I think I now have a different understanding of the test. You know, when it's doing the test, maybe I'd like to read some paper on the input shaper. Yeah, I think paper would be better. I mean, I'm just trying to go logically without reading or doing anything. So that's the way I like to do it. But going through papers might be a better idea. So if you go this way, okay, it's going to vibrate. So it's going to ask this guy to go at a certain acceleration. So let's say 200 millimeter second square to that direction, and then it's going to ask him to, once it arrives here, then he's going to ask him to do a minus, okay, a suddenly change, and that will create a jerk. Okay, the jerk value is going to be I don't know exactly the value, but let's call it 400. I mean, it's definitely not how you do it, but let's just put 400, and then okay, so this will make it vibrate at a certain frequency, and then you will do it again. He will do again. Okay, now you go back at 220. Okay, now you go back at 220. Okay, so let's say it go 210, and then go back to 100, and then go to 20. So that was gonna be let's say 420, etc. And then again, then go back at I don't know. Let's you go back at 230 minus 230, and that's gonna be 50, right? Something like this, right? So it's changing every time. So it's doing that vibration. So it's asking a certain acceleration on one side and then on the other side, and then it's going to create different levels of jerk. And this data is the one that correlates with each frequency, right? Each frequency correlates to a change of acceleration, like a sudden movement of your system. Okay, that sudden movement creates a certain frequency. And then during the printing, it will, depending on the change of movement, then it will create a certain frequency. So now I'm lost again, because even if you have a small jerk, if you have a small jerk, the amplitude, actually oh my god, my brain is dead, because there is also, hey, Ian Douglas, how are you? Thank you for the raid. You arrive at a moment where my brain is exploding, because there's also the amplitude that is important. So I guess, so yes, so a jerk is correlated. It's correlated to a certain frequency at a certain amplitude, right? Or like a porous spectral density. So the lower like how does that correlate? Is that the lower the jerk, definitely the lower the amplitude, but not lower the frequency? I cannot think anymore. RC Maniac, how are you? Thank you for being awesome, Builders Mark. Sweetie Jeff, how are you? Sorry, I'm losing my mind. I'm losing my mind. I'm getting there. I know I'm getting there, but it's not easy. What's my frequency, Kenneth? Little John, my control system theory understanding is not that strong. We had a whole control system department next door to the electrical and electronics engineering department. I was a researcher at, but I never attended any courses there. I'm trying to follow what you're saying. Definitely would be something I would read up on. I'd like to read some paper, blah. I posted another pic on the Discord of what I mean. You have a porous spectrum in this graph too. Pure 5 kilohertz, sinus wave, blah, 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 Fourier expansion, blah, blah. A pure 5 kilohertz square wave measuring at 1 volt, and then the Fourier, yeah, okay. That's okay, Nick. You lost my mind. Yeah, it's not easy. But do you follow at least? Do you follow, like, where I'm getting at? Like what I'm trying to do is I try to understand, why would we round off the corner? Okay, I'm trying to understand the logic behind that. I mean, yeah, it's intuitive. It's intuitive, right? But that's not enough. Why does it do that? So right now I arrived to a point where it's breaking down the sudden change of the printer, which is translated into the jerk, right? So instead of having a high jerk, which means a high change in movement, or like a sudden change in movement, it's now a lot of small change in movement, okay? And I define this as jerk. That's the data I take. Now, how does each jerk would have a certain frequency, but where I lost my mind is how does it correlate to the amplitude? Like, is it because the more sudden you change, and I guess the higher the amplitude, but how does it correlate to the frequency then? Anyway, so that's where I lost my mind. Or maybe that's what Sebastian is trying to say. There is no one frequency. Everything. Oh, maybe that's what he's trying to say. Maybe when you change, so the jerk is related to the amplitude, and the frequency, it's anyway, everything is going to vibrate at different frequency, but it's the amplitude. Oh, maybe. Yeah, there's no one frequency. Oh, okay. I think I'm getting to it. I'm getting there. The motion system is a resonance system, so you want to cut out frequency above the resonant frequency from any corner. I follow the cutting out the high frequency from the Fourier decomposition of the corner. The bottom one is a square corner. If you throw out frequency, you get something that is round. Yes, I mean, I know that. Sebastian, but I'm trying to correlate what's happening on the printer, the G code and everything, and this, because I mean, all the mathematics behind, I think it's okay. I mean, I think I have a pretty good understanding of this. I mean, that's academical, right? That's what we learn at school. But how does that, like, how does that correlate with what the printer is doing? Like, how does that correlate with acceleration, with jerk, with position, with all of that, with G code? That's what I'm trying to do. Because all the mathematics behind the algorithm, blah, 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 yeah, maybe I don't have a super understanding, but you just go on Wikipedia, and I mean, I think most of the people understand that. But the problem is people stop there. Oh yeah, that's logical because of this. But no, there's nothing logical. How does that, what the printer is doing? Yeah, it's kind of adding some frequency. But what does it do? You cannot add the frequency. You can make the printer move faster or low or slower or in different direction, but you cannot just add frequency. You get what I mean? You want to sanitize corners only from frequency the printer can produce. Without input shaping, with high speed and high acceleration, when the head hits that corner and changes direction, vibration happen, yeah, and you get ringing in the print, yeah. Input shaping is compensating for that. Too much sound on corner. Yeah, Kevin, this I understand, no problem. But how does it do that? How is input shaping compensating for that? Too much rounds of corner, too little gets ringing. The shaper attenuates the power spectrum on the right there. Then it's not a square anymore because frequencies are missing. The more frequencies you remove, the more you get from a square wave to a sine wave. The shaper attenuates the power spectrum. But why nobody is talking about 3D printing? Like, how do they correlate to 3D printing? Or is it me? I'm missing something? I'm the only one talking about a nozzle that is moving. Zombie, I need help. A nozzle that is moving at different speed, etc. Why are we talking about frequency still? I think we finished the frequency thing. We know how to attenuate. We know the blah blah. We know that. Maybe we should continue next time. Input shaping has been used in heavy industry for years. CNC routers, not my area of expertise. Yeah, there's a lot of technology that arrived to 3D printing that come from CNC and stuff like this. It's just a motion system. The fact it's a nozzle doesn't matter. It's control theory. Well, it does matter, right? How does it move? How does the nozzle move? We cannot, because right now what people say is, even if you go on forum, what people say is the printer vibrate at a certain frequency, and input shaper is attenuating this frequency by doing a negative frequency or something. Is that enough for you guys? For me, it's definitely not enough. What does that mean? I never ask my slicer to ask the printer to move at this frequency, or the printer is never giving the command of moving at that frequency. He thinks that the time between Amazon subscription shipment. What? Do you not understand frequency yet? I understand what frequency is. I want to correlate that to 3D printing. 3D printing. The G code. This kind of stuff. It is at high speed, modifying the speed of movement of the steppers to cancel out the ringing that would result. The modification is generated by Dou's algorithm. It is a high speed modifying this. What? It is at high speed modifying the speed of movement of the steppers to cancel out the ringing. So you mean it's so the pi is changing the speed, the printing speed? Is that what it's doing? It's lowering the printing speed? Of course, the step commands correlate to a frequency after all. Doesn't an input shaper teach itself what the frequency is by a test prior to printing? Yeah, Michael. So before printing, it does this, right? It makes it vibrating. So it asks the nozzle to move right and left at a certain acceleration, and it slowly increases that acceleration, and then it gets the output, which is the frequency, and some kind of power spectral density. So that's what the test does. And then from that, my guess is every time it receives a G-code command, it calculates what acceleration and jerk, so that, and then it correlates that to a certain frequency and a certain power spectral density and compensate that. Kind of something like this. No, G-code change, just firmware filtering the motion. Just okay. So there is no. But how can the G-code be the same and the printer do something else? How is that even possible? Little John, how can we not change how can we not change the command the printer is receiving and hoping that the printer is going to do something else? One move turns into a bunch of smaller ones. Yeah, we know that, Zombie. But why? Why does that make it better? The calibration test, yes, I believe that's how it works. It determines the mismatch between what it expects and what it actually senses, then adjust accordingly. It determined a mismatch. Oh, do you mean that we send some command, like 200 millimeter square, second square, and then we check what it's really happening? So maybe 197. So that's the real. And then it will compensate that by sending a slightly higher one, like 204, and then the 204 will result into an actual 200. Oh, okay. Is that what he's doing? So that we always have the proper acceleration? Look up Fourier entities because it filters the motion, to the motors. Okay, we're reaching my my brain limitation, which is not that high, I know, but but how does it do that? Like there is a PCB in the stepper motor that do that automatically, or it has to do that before sending the command, right? Yeah, it has to be a change in the command. I don't think the stepper motors, they're that smart. The firmware takes a move and convert in another move. So is there a change in the command or not? For me, I think so. I think it has to change the command. Lowering speed and increasing speed at just the right time to get good corners. At high print speed, many steps that would, if built into the slicer file, would result in an over large G-code file, and the motherboard and the printer wouldn't be able to keep up. Hey, Bichi Cognito, how are you? Lowering speed and increasing speed at just the right time to get good corners. Okay, so it's okay. So it's a speed change every time to get good corners at high print speed. Many steps that would, if built into the slice file. Yeah, I mean, I'm not saying it. The slicer, the G code you will input will. What I'm saying is you have a G code that goes into the Pi, and then the Pi is sending another G code. Is the Pi sending G code, or is sending something else? Or is the G code just something that is for the Pi, and then the Pi translate it into electric command, and we'll just send other electric command to the printer? So that's why you say the G code doesn't change. Zombie, do you want me to join? Yeah, if you want, but I will stop soon. In 10 minutes, I will stop in 10 minutes because I need to go downtown. But let me send you. There you go. I just sent you the link. But I'm warning you, I'm losing my mind. I'm losing my mind already. Yes, that's my suspicion, and it acts below the level of G code. So G code to input shaper to printer. Fourier synthesis is basically making shape out the sine wave. If you throw away certain frequency, the shape's accuracy goes down. What it expects is part of the algorithm. It is not mind reading. Oh, there you go. Welcome, Zombie. How are you?
How's it going? Good.
Not good. It's not going good.
Not good. All right.
I'm losing my mind.
It sounded like you need an extra little bit of maybe different direction or a different way of thinking about it.
Yeah, I'm going crazy there. Sorry guys, I just skipped all the chat. I just realized I was very far behind.
It's just little John telling all the right stuff. Don't worry about it.
The Pi code and sends movement command to the MCU, which then control the motor. Okay.
Yeah.
Okay,
so
anything?
So from a high level, this is how I understand it. You have your G code, which is an input to the firmware, and the firmware has to interpret that somehow, right? So every firmware is going to interpret G code differently, and it's going to tell it's going to use the microcontroller to then send the correct signals to whatever device. So it's all electrical, right? So when you're saying move from A to B, it has to do a lot inside to actually control it. It has to adjust currents, has to adjust acceleration, so it has to control and send the correct signal to make that motion. So what Input Shaper, what I believe it's doing, is it's altering what would typically be, an acceleration and deceleration curve into something that looks more like it's accelerating, and then it's decelerating, and then it's like stuttering. It's like stuttering the motor back and forth to create the opposite resonances that the printer is experiencing. Does that make sense?
Let me think.
So I had a way I was going to explain this. But, let's say you're traveling really fast, right?
Yeah.
And you stop. Let's say you're attached to a spring. You're going to want to keep on going.
Yeah.
And then bounce back. Well, what the Input Shaper algorithm is doing is saying, okay, well, I measured how much springiness there is, and now I'm going to have a rocket booster, and I'm going to, as I'm accelerating, I'm going to apply force backward to slowly stop. So it's a fancy way of braking, that's all.
Okay.
by inverting so you're actually moving the motor in the opposite direction.
Okay.
Like sending opposite signals. And each one of those algorithms is going to do that differently, with more or less ways of controlling it. And the more aggressive it is, the harder it will be to accelerate, and the more artifacts you're going to get, because it's kind of canceling out too much.
Yeah, so that's the part I don't really understand. Like, what would we transform a corner from being sharp to round if we just do what you said, right? We just brake properly and then reaccelerate properly. Then it's still a corner, right?
Because you're slowing down, you're not allowing it to hit its final destination. Like, it would be, if you go slow enough, it would be fine. But the issue is when you go too fast, it has to apply a lot of force in the opposite direction. And so much force that a typically, sharp move now has to become slowed down and reaccelerated. So it's going to just curve or smooth out the detail.
But that doesn't give a rounded corner, right? That gives a corner that is not 90 degree anymore. It's a corner that is like, how does he know? Yeah, I still don't understand. If you stop too early and then you go in the other direction, you're gonna have like it's not a square, it's gonna be a parallelogram.
Yeah, that's something that's I'm not really as sure as the answer either. Like, why it makes sense from a higher level, but what it's actually, it would be nice to see line by line what it's actually trying to do. That'd be interesting.
I mean, the high level stuff, I think I also understand, right? What I'm trying to do is to go a bit deeper to see what's exactly is doing. Anyway, I think we learn a lot of things on the way as well. We don't have to reach the destination to learn something. But yeah, I'm sorry, but my brain is is done. It's only been 2 hours. I think that's the fastest way I've fried my brain.
It's a lot to think about.
Yeah, but anyway, yeah. Thank you, Zombie, for having some other explanation. I think the more, and that's the thing with our community, is the more we understand something in details, the easier it's going to be to explain to some other people.
Yeah.
Do you do a third part after the New Year's holiday? Well, I guess so. We haven't really reached what I wanted to reach, but I guess if we want to go further, I will have to do some homework, unfortunately. So I will have to watch some video and do some stuff like this.
Well, how about this? If anyone in chat has any more, he likes the scientific articles, so if you can find any like videos or deep dive analyses on what the code is actually doing in the processor, because I know it's a bunch of math. It's going to be it's a system. It's a system engineering issue, and that's not something you can just talk about on stream. But if there is some type of maybe summarized explanation of what's going on.
And yeah, Little John, usually you will find out that any Printbuster topic will go so far that Google start to have its simulation. You will find that often.
Yeah, that's the point, though, is asking the questions that, like, why? Like, why can't we have bamboo speeds but actual quality at the same time? Like, why can't we have that? And it's important to get those expectations when you're trying to make new things. I'm in the house. Yeah, I'm in the house, and I'm gonna head out. I actually have to start my stream. I'll be doing some upgrades of the printer. So here, I'll share with you a sheep. This will get you a little less tired, right, sheep?
Fluffy sheep.
Fluffy sheep. It's cute. It's cute.
Yeah, I mean that's the value of Printbusters, right? We want to add value to the 3D printing science. So if it exists already, then great, we can summarize it, and if it doesn't exist, then we'll have to make some tests and stuff. So anyway, so
right. Cheers.
Yeah, see you, Zombie. Have a good stream. I will most likely send the people to you because I finished. I will do the giveaway and then I will
All right,
go.
Sounds good.
So yeah, talk to you later. See you, Zombie. Bye. Okay, so you can't get speed and quality because of mass. Yeah. So yeah. Thank you, everyone, for helping my brain to survive this learning process. I know sometimes it can be frustrated when you're watching someone that doesn't understand basic stuff, but I'm slowly learning. I think I'm getting there. Thank you for staying by 2 hours. I think that's the fastest Printbusters. I fried my brain. I fried my brain pretty much all Printbusters every time, but this time it went pretty fast. Here's something that might be relevant. You know what I'm gonna do? Before I'm gonna open a Printbuster on Discord. So I'm gonna call it what is input shaper actually doing? Okay, so I'm gonna share that, and then share your thoughts, data, resources, and references on this topic. And then let me put a graph as a nice picture. I put the graph from Clipper 3D, and then post. Okay, so now you have a new Printbuster post. By the way, there is some other Printbusters if you're interested in frying your brain. Why are some materials warping more than others? Why some materials warp more than others? You're gonna fry your brain in 15 minutes minimum, maximum. How dangerous are 3D printing fumes? What explains the 3D Penchy hull lines? This is also a very interesting Printbuster. Does drying make filament less brittle? How 5 minute max. How should you calibrate each step and flow? This is a very interesting topic. We also fried a lot of brain with that topic. Is FFF 3D printing food safe? Also an interesting one. And our new one, what is input shaper actually doing? Anyway, it's making Nick's head explode. Okay, so yeah, you can share everything because all what you shared in general and in off topic will disappear over time. So we need to keep. Oh, awesome! Thank you, Toronto Dad. Thank you, John. Thank you, everyone, for sharing that into this channel. So we're gonna draw our survivor of this Printbusters. 37 entries, 71 viewers. Okay, so you guys came to fry your brains, not for the giveaway. So that's very good to know. only 37 entries. Oh, I'm getting tired. Yeah, 3D Jeff. I'm glad it's useful. I'm glad the Printbusters is useful. I mean, sometimes I'm a little bit in my bubble trying to understand, but I'm glad it helps some other people having some. Like I said, it doesn't matter whether we reach the final line, right, of total understanding, because it's along the way that we learn the most. We learn many things. That's why tangent is not a big problem if it's not like a large tangent. But we learn, like you see, I learned on the PCB what was the MCU, what was the RAM, what was the accelerometer. It's some small thing, but it's some small learning that you have along the way. I learned how to install the kit. I learned how much was the kit and this kind of thing. All the stuff along the way is very interesting as well. Michael, about polymaker carbon fiber filament, do they use mill fiber? Is the fiber length documented? Don't see in the TDS. We use mill fiber. The fiber length you can ask on Discord. It's not something entirely public, but if someone asks, we will answer. Okay, so we good. Just pose the question again if I missed it. Otherwise, I will do the giveaway. So only 37. Is it broken or? Yeah, maybe it's broken. I came late for the brain workout, but I'll do more later. I really like the aspect of 3D printing. Yeah, I think we broke our giveaway as well. Sorry, I will have to restart it. It's definitely broken because we have more than 70 viewers. It's broken. Like actually, the last Printbuster we broke it also. I don't know why. Looks like it has a brain also. So yeah, just be awesome one more time, and then I will draw in 10 seconds. So I'm going to draw. Okay, let's bring that up. Maybe 50. Yeah, you see, it was definitely broken before. We already surpassed the 37. Okay, we're gonna draw in 10, 9. Do you want to learn the Chinese number? So 10, 9, 8. Come on. 7, 6, 5, 3, 4, 2, 1, and drawing. So, congratulations to Corcon from YouTube. We have more and more. San RE. Oh, Corcon, congratulations. Oh, Corcon from YouTube, not Corcon from Twitch. Corcon for YouTube, are you still there? Oh, I know what you guys are doing. You guys are entering from YouTube and from Twitch, so that you have twice the. Then you have 2 tickets. I know what you're doing, because I saw Corcon on Twitch. He answered on Twitch. No, I'm not on YouTube anymore. I know what you guys are doing. Anyway, so congratulations, Corcon. Bank contact in the chat to reach out to me. Bank contact, and then we'll go. If your brain has survived, hedgehog. If your brain has survived so far, oh, why did I do bang red? Is slash red. You see, my brain is done, completely done. I have to stop. Okay, should be here. Yeah, now it's good. Yeah, Corcon is there, right? Yeah, he is there. I can see. So thank you again, everyone, and again, I will most likely continue the stream next week. So next week is the big holiday in China, the Chinese New Year. But we'll continue the stream. So I will see you next week. You can jump on Discord if you want to continue that topic. We have a lot of nice application channel on Discord. So thank you again. Have a very good holiday. Well, no, you don't have holiday, but have a very good night or day, depending on where you are. And I will see you next week. See you. Thank you.